We're going to look at section 2.2, verifying trig identities. There's some, ultimately they're really the same steps that we had in 2.1b when we were going through and trying to simplify the expressions. But just a reminder here, we're working with one side at a time, so try not to use two sides. These equations, when we're verifying, you're going to get the problem on the left and then equals a problem on the right. So we want to make sure that that we try to use just one of the sides and not work with both sides. But you can work with both sides, but ultimately you need to get back to the fact that the left side actually does equal the right side. You need to make those two things look the same. So in order to do that, you want to look to factor. You want to try to add and subtract. You want to try to square a binomial. You want to create a common denominator. You want to go through and ultimately just try to find something that you know how to do, and you can move to a different way of the equation looking. Number 3, you want to look at using fundamental identities. That includes the Pythagorean identities on your worksheet. You want to note which functions you want at the end. So if you have the left side and it has, let's say it has sines, then the right side has cosines. Maybe you want to look to try to look for sine squared so that you can turn that into a cosine squared. Those types of things. They say same thing with secants and tangents. Same thing with cosecants and cotangents. Those things in the Pythagorean identities, those things match up with each other. So try to look for that. And then number 4, if you're stuck, try to convert it to sines and cosines. Okay, and that is ultimately the first way that we looked at in the last section. And so you go ahead and try to do that. Ultimately, if you end up doing that in most of these problems, you're going to end up going a longer route than you need to. But try something. It's okay. Take a break. Okay, if you get stuck, take a break. Come back to it. These problems are not the easiest problems in the world. They take some unique thinking, and that's what we're going for. That's the whole point of it. Number 5, always try something. Okay. Even if you're stuck and you don't know what it is, try to ask somebody what they did. Try to ask either myself or look it up in a book. Look at your sheet. Look to see if there's any conversion that can happen. All right, go back and try something. These are problems that you can easily lead to a dead end. They can easily get you to a place that you think that there doesn't make any sense. Okay, and so even if you're trying to start over, that's okay. Okay, and you're going to get stuck, but those dead ends have provided a place that that you know that you shouldn't go, and so it's actually providing some insight as well. All right, so let's take a look at some of these. Here's a trig identity that we want to verify. So we're verifying, so we want to make sure that the left side equals the right side. And so ultimately, I need the left side to be sine squared theta. Okay, so I need those two things to be equal to each other. And so the first thing that I see is a secant squared. Okay, and when I see a secant squared, I want to know that in my Pythagorean triples from the worksheet that secant squared is equal to tangent squared minus 1 plus 1. And then I've got minus 1 on top and still secant squared on the bottom. Okay, so well, that's the first thing that I see when I see this. Now I have a plus 1 and a minus 1, so that actually is a tangent squared theta divided by secant squared theta, because the plus 1 and the minus 1 cancel each other out. Well, I am going to look at this and think about the tangent squared being sine squared over cosine squared. And then the secant squared is 1 over cosine squared. And I know that I can go and I can take two fractions divided, and I can take the first one and multiply by the reciprocal of the second one. And these cosine squareds are now going to cancel out. and I get sine squared. Okay, I and so in writing this, it probably would be better for me to take these equal signs off the left side here and actually put them on the right side, because ultimately what my goal was is for this left side to actually look like the right side, and so I want to keep it on the left side of the equation. Don't move that equal sign. And so I want to keep this. This sine squared is going to follow along. It's going to follow along the whole way, all the way down to the bottom. And I want to make sure that sine squared is equal to sine squared. Then that's true. Okay, this little box means that it's the end of the proof. But it's not truly a lot of proof in here, but we're verifying that the left side actually equals the right side. Once that happens, then you know you're done. Okay, so I end up with this being the answer. Ultimately, you have the answer, so I don't really care if you put a box around it or whatever. What I'm looking for is not the answer at the bottom, because anybody can write the answer equals the answer. What I'm looking for is the steps in between that allow you to get to that point. And so the important part is the steps and not necessarily the answer in these problems. I'm going to come back to that same exact problem here, because some of you might see a little bit different way, and if you see a little bit different way, then that's okay. These trig identities, they can be verified in lots of different ways. So some of you might see that this is a fraction with a minus sign in between, which means that I can separate these two with the common denominator. Secant squared over secant squared is 1. 1 over cosine, or 1 over secant squared is actually cosine squared. Well, 1 minus cosine squared is a Pythagorean triple, so or Pythagorean identity. So when I go to my chapter 2 resource sheet, I see that 1 minus cosine squared actually is sine squared. And now I end up with sine squared is equal to sine squared, which is the end of my proof, and I'm done. Okay, it's a little bit easier, but the thinking around it is more complex. It's the fact that I've got two different fractions with that subtraction in there, and so the thinking is really the same. The work is going to be a little bit different. It's going to be a little bit shorter, but ultimately you need to go through, you need to work the left side so that it ends up looking like the right side in any way that you feel like would work. So that's my spiel on yours. Doesn't have to look like mine, but here's a few other examples in case you were stuck and didn't know what yours needed to actually look like. So in this problem, I've got some sines on the left and some secants on the right. So ultimately, I'm thinking that I am going to have to turn that sine into a sine squared, because I need the secant to match up with cosines. So sine squareds and cosine squareds match up if I get them in the right order. And so then again on the left-hand side, I see that I have some fractions. Okay, and so these fractions, they have an addition in between, so I'm going to look to try to add those fractions together. In order to add fractions together, they have to have a common denominator. So that means I had to multiply this one times 1 plus sine theta on top and bottom. And I have to multiply this one by 1 minus sine theta on top and bottom. So on the tops of this fraction, I have 1 plus sine theta, because that times 1 doesn't do anything. On the top of the right fraction, I have 1 minus sine theta. On the bottom, now I have 1 minus sine theta times 1 plus sine theta as my common denominator. Now I look at that and I see on the top that I have a plus sine theta and a minus sine theta, and I have 1 plus 1, which is 2. In the denominator, I have two binomials that I can multiply using FOIL. So I have 1 times 1, 1 times sine theta. negative sine theta times 1, and negative sine theta times sine theta, which is negative sine squared theta. When I go through and simplify on the bottom, these sine thetas are going to cancel out. I get 2 over 1 minus sine squared theta. There's my Pythagorean identity. 1 minus sine squared theta is actually cosine squared theta. And then finally, cosine squared is actually in the denominator comes, if I bring it up to the numerator, I end up with secant squared, which is exactly what I wanted this to look like. Okay, so I made the left side look like the right side. 2 secant squared theta is 2 secant squared theta. If you wanted an extra step in there, this would be 2 times 1 over cosine squared. The 1 over cosine squared is going to become secant squared. So if you wanted that extra step, it's in there as well. Now, chances are you're going to go through and you're not going to go through and get that problem on the very first try. Okay, so give it a try, keep going, work at it, and then ultimately you will end up with this 2 secant squared. Here's another one. So I've got tangent squared plus 1 times cosine squared minus 1. Again, it looks like I have 2 binomials that I could multiply, so that's one way that I could go through it. But if I see I have tangent squared, I ultimately want to look and see if I have a Pythagorean identity that will substitute in for that. And I actually do, because tangent squared theta plus 1 is actually equal to secant squared theta. Same thing with cosine squared minus 1. I could leave that and I could use the distributive property, but I want to look and see. I know that 1 minus cosine squared is equal to sine squared. So when I flip those signs, when this is the cosine's a positive and the 1's a negative, I've just multiplied that sine squared times negative 1. So this is actually negative sine squared theta. Okay, and there's some thinking that goes into that. Ultimately, you're multiplying the cosine squared, 1 minus cosine squared times a negative 1, and so you're multiplying sine squared times negative 1. Okay, the signs are just in a different place. You could think of it as factoring out a negative 1. That would be fine too. So I go through and I see that I have a secant squared and a sine squared. Well, secant squared is 1 over cosine squared. Don't go back and change this into a Pythagorean identity, because then you're just going back to where you started from. So you want to keep moving forward, try something different. On the tops of this now I have negative sine squared theta, 2 fractions multiplied. On the bottom I have cosine squared theta. Sine squared over cosine squared is tangent squared. Well, that's exactly what I wanted. I wanted the left side to look like a negative tangent squared. I'm done with that. And that one wasn't so bad. Okay, and look at using those Pythagorean identities when to start, as opposed to going through and maybe trying to do some multiplying. Okay, you could have gone through and used FOIL and that would have been fine. You would have ended up in the same place. May have taken just a little bit longer. Well, let's take a look at just one more here. On the left-hand side, I've got addition. On the right-hand side, I've got multiplication. So ultimately, that means that I'm eventually going to have to put together fractions, and then I'm going to take them apart. That's what it means. So I'm going to create fractions. So tangent theta is sine over cosine. Cotangent is cosine over sine. I'm going to add these together, so I have to get a common denominator. It means I'm going to multiply this by sine theta, and this by sine theta, this by cosine theta, because that's what's missing in the denominator, by cosine theta. So on top, I end up with sine squared theta plus cosine squared theta. On the bottom, sine times cosine. And then I want to make that look like secant and cosecant. Well, I have the sine and cosine part on the bottom, so that's good. On top, I have sine squared plus cosine squared. That looks like a Pythagorean identity, so I go, and it is. It's sine squared plus cosine squared is equal to 1. So now I've got this fraction where I've got the right things in the denominator, but I want them separated. So I'm going to say this is 1 over sine theta times 1 over cosine theta. 1 over sine theta is cosecant. 1 over cosine is secant. And just can put them in the same exact order. They had secant first as the problem. So we'll switch them. And when you watch this video, you think, oh, this isn't going to be so bad, and so then some of you are going to stop and not go and try the problems. Try the problems. You have to try them. This is not a spectator sport. Mathematics means to learn by doing. So go and work on these. Okay, try to get through a few of them. If you get stuck, take a break. Ask questions. Okay, but ultimately keep going. Keep trying something.